In this presentation of the pixel processing software, we're going to take a look at how we can try to find measurements of things in images. To do this, we're going to use the trick of homography, and this allows us to relate or transform the points found in the plane of a calibration image to a plane, an arbitrary plane that is perpendicular to the camera and rotated so that the calibration points align with the rows and column of pixels. You can read more about this in OpenCV's Find Homography documentation. There's several things that we need. We'll need an image to measure. And we need to make a mask of this image. So for that we'll just do a basic threshold. And this will be image 1 that we're thresholding. I'm going to put this in image 2, and we can look at the values around the edges of the object and inside, and maybe a threshold value of 125 might be okay. And you see we have a decent mask of this envelope that we want to measure. We go to the measure operation, and we're measuring a polygonal shape. The calibration board, we just need one of those calibration images, is in image 0. The input image is in image 1, and the mask image is in image 2. We have to put in the proper pattern information. So this is a grid of circles, and this particular grid is 12 by 8, and measure the distance between the centers of each circle, and this one happens to be 21 millimeters between the centers, both horizontally and vertically. It's okay if they're not square, but you just have to put in the right dimensions. We also need a camera calibration file for the camera that was used to take the image of the object and the image of the calibration board, and I used the Logitech camera for that, so I load up the calibration JSON file for that. And again, the homography does a couple things for us. One is it allows us to translate or transform the plane, and the object must lie in the same plane as the calibration board, and allows us to translate or transform that plane into one that is perpendicular to the camera and rotated so that the calibration points are aligned horizontally and vertically with the pixels of the image. That last part, aligning the calibration points with the pixels of the image, allows us to do what I call a pixel calibration, where we can determine the width and height in millimeters, or whatever our units are, of each pixel. So once we have all this set up properly, we can apply a measurement. And I've got the destination image as 2, so this is going to write over our mask. I should have put it in the third one, and then if we view the results, we can see the measurements that we got on our polygonal object. And we can compare that with what we actually measure. So it looks like the width of this envelope is about 163 or so millimeters, and we're getting 162 point something. And the height of the envelope looks to be about 123, 124 millimeters or so, and we're getting 121, almost 122 point something. So there is some error here, and I want to point out a couple of sources, potential sources for the error. One, let's look at the original image that we're trying to mask, threshold and mask, and find corners and find shape. A couple of things to note. One is this top corner is not very square, it's a little bit rounded, so we didn't get a great view of this top corner. Also, you can notice lossy compression artifacts around the edges, and this is due to the simple webcam that we're using. It gives us an image stream, a video stream that uses lossy compression. So we're getting these compression artifacts that may be interfering with us finding a really good edge. But we're fairly close in our measurements, considering that we're using a simple webcam. Let's look at another example. I have a DVD here, and in order to make a mask of this, I'm going to use the find circle or find ellipse tool, and we're going to start the radials from the outside, and I think the rest of these parameters are pretty good. And we'll put this in image 2, and if we apply this, and we can see that we found a decent fitting ellipse. There's some error here, maybe due to shadows, but it's a fairly decent fit. So we're going to replace the markup image with a mask image, and now we've got our elliptical compact disc or DVD. So let's see if we can take a measurement of this. And we're changing from a polygonal shape to an ellipse shape, and we'll put the output in the third window here. And everything else is the same. The calibration board doesn't change. The input image and the mask image are different, but the calibration information for the camera or lens calibration doesn't change, and we've got the same pattern and distances. So if we apply this, you see that we got measurements of the ellipse of about 119 point something millimeters, and that makes sense. A standard DVD is 120 millimeters, and that's about what we measure here. Also notice in the message window, when you do the measure operation, it tells you what the pixel calibration was, or what the size of each pixel when we do the transformation of the calibration board using homography to a plane that's perpendicular to the camera. It does a pixel calibration, and the output here in the measure window shows you what pixel size was computed. So this is a good demonstration of how we can try to use the software to take measurements of objects using the trick of homography. For more computer vision demos, or if you'd like to try the software for yourself, please visit pixelprocessing.com, and feel free to leave comments or contact me. Thanks for watching.